Okay. Do you have any doubt from last few
No
classes?
doubts. No doubts. Very clear.
My screen visible?
Yeah, I can see your screen.
Mhm. Okay. So basically today we will study some concept first, because after that we will take numerical from those concepts. Okay.
Okay.
This brief introduction about the concept. I'm not going to derive it because I don't think that you required it for derivation, right?
No, no need.
Okay.
Yeah. For the paper as well, I'm able to like have a like if there's a lot of equations, I can write them down on a sheet of paper and bring that for the exam.
Right.
So I don't need to memorize or do derivation.
Okay. Let's do that. Till now, what we were studying, that we have a one interface and we have two medium, right? Reason
Yes.
1 and reason 2, right?
Yes.
Okay. And
Yes.
we are seeing the characteristics of the medium reason 1 and reason 2 that are having the different characteristic, different permeability, conductivity, like that. Okay. Now we
Yeah.
will see.
Okay.
Now we will make the constraint that our region 2 is my conductor. Okay. Is my conductor. Okay. Is my conductor. Reason 2 is my conductor. That means that its conductivity is now very high, infinity. Okay. So what happens
Yes.
in this type of case, if my electric field is incident on the interface of the medium, the electric field will get totally, the field will get totally reflected back. Okay. So what I want to say that in the case of interface between reason 1 and reason 2, in which one reason is conductor, then we have the reflection coefficient is -1 always. Okay.
So wait, so if it's a conductor,
Okay.
if it's a
Yeah.
conductor, does that mean conductivity is infinite? Like, is that an assumption you can make?
No, that is not a junction. That is the sigma is what? Sigma is conductivity, right?
Yeah.
If it is conductor, it means that my conductivity parameter is infinity, right? Is
Yeah, so it
very.
does no. So it does mean that. So if like in the problem, if they say like region 2 is a conductor, I can then say that sigma is infinity.
Infinity,
Or
right,
yeah,
right,
yeah.
right.
So what was the one where it's like sigma is really high? That's just good conductivity, right? That doesn't mean
Yeah,
actual conductor.
yeah.
Okay.
But sigma is
Okay.
very, that is the ideal conductor. Are you getting it?
Okay. Yes, yes.
See, till now, what we were doing till yesterday, we were comparing the conductivity.
Yes.
Every body has some conductivity,
Right.
right? But you can't tell that this is a conductivity, this is good conductor or bad conductor, something like that. But in this
Yeah.
case, you can tell that this is a very good conductor because its conductivity is very high. You do not need to
Yes.
compare it with any other material, right or wrong, because its conductivity is very high.
Right.
Okay.
Yes.
So in this type of case, we can straightforward say that our reflection coefficient is 1, because whatever being incident, it is totally getting reflected back. Okay.
Okay. Yes.
Are you getting my concept? Whatever being incident is totally getting reflected back. Okay. So reflection coefficient is -1, then transmission coefficient is 0, because nothing will get passed to the conductor.
Get past. Right. That makes sense.
Okay. Any
Yes.
doubt till now?
No doubt.
Okay. 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 Yeah. See. Okay. Okay. This is good. And I don't want to give a lot of formulas. I'm giving some formulas. There is one concept of null. Location of electric field null. What do you mean by null? If I'm telling that location of electric field null, it means that suppose we have an electric field.
What is that line after the L?
This is not, this is just just notation.
No, but there's like a line before that. It's NULL, and then what's that slash?
NULLS, nulls.
Okay.
NULLS. NULL
Oh, okay. Got it. Okay.
nulls. This is your electric field, suppose. Incident electric, okay?
Sure.
Let me draw much clear.
But I thought electric field is in the X direction.
No, I am not telling that electric field is, I am just explaining you.
Oh, okay.
Okay, this is my incident electric field. My incident, my reflected field will be like that.
Okay.
Okay, because reflection coefficient is -1, right or wrong?
Right.
Okay, so they are asking that where you will get nulls. Okay. So we can, and one more thing.
Why is it flipped and not the same?
Yeah,
The
it should
waveform.
be, right? Till yesterday we were learning if is my incident field, reflected field will be
No. I understand it's in the opposite direction. My question is, why does it not follow the same path?
How can it follow? If it is as a magnitude EM, it should have magnitude minus EM, right or wrong?
Oh,
Because
right. Okay. No,
what
that
is
makes sense. Yeah. I got it.
ERY EI that equal to -1,
Okay.
right?
Right.
Okay.
Yeah.
Now we have the location of electric field nulls. Okay. Nulls means that
Are
where these
those
field are
they
getting
intersect?
zero.
Yeah.
Okay.
Okay.
Yeah. Basically, here we talk about the zeros.
Will
Okay.
they always intersect at 0?
It's
The
depend upon the
intersection.
yeah. In this conductor, it will happen because in this conductor, what will happen? They are getting totally reflected back, right?
Okay. Yeah.
Okay. So basically, what happens here, and one more thing, this is your wave, okay, and this wave time period is t, right? Right or wrong?
Right.
And this wavelength is denoted by lambda, right or wrong?
Right.
Then half wave, can I say lambda by 2?
Yes.
Okay. So can you tell me after which point the nulls are being repeated? Can I say that after every lambda by 2, we are getting nulls, right or wrong, in a wave?
Right. Yes.
Right?
Yes.
Here, nulls is occurring at which point? Is it occurring?
Yeah.
It is starting at 0, right? So location
Yeah.
of electric field nulls is n lambda by 2. Okay. Where n is 0, 1, 2, 3. N is integers.
I see. Okay. Yes.
Okay. Because it can occur at various places, right? It is
Yes.
wave, right? This is my incident wave. This is my reflected wave. Nulls will occur after every lambda by 2. You can see.
Okay.
Right or wrong?
Right.
So electric field nulls will occur at this point, right?
Yes.
Similarly, I'm not going to derive for the magnetic field nulls. I'm just writing the equation for magnetic field nulls. Okay.
Okay.
Location of nulls. Okay. That is nothing but z equal to 2m plus 1 lambda 1 by 4. Okay. And this is location of magnetic field nulls. Okay. Here again,
Okay.
m is can be 0, 1.
So do you use Z for both electric field nulls and magnetic field nulls?
Yeah, there is no issue. Because Z is
Okay.
the, don't go with it. This is the just case that we are taking. It can be any direction. We can't tell that
Yeah. I know. I know. I'm not
It can
saying
be
direction. I'm just saying variable. Like use same
right.
variable.
We can say
Yes.
state anyway.
Yeah.
Okay.
No, that's fine. I was just wondering. Okay.
Okay. M is integer. Okay, this is the formulas that is required for your next questions. Okay, just see once. Okay, if you have any doubt,
Okay,
you
so
can ask.
magnetic field is a little bit more complicated then. Like that's why it's 2m plus 1.
It will not complicated in your solution. It will not work. Just observe it. If you have doubt, you can ask.
Oh, so it's every half, but it's shifted by like a quarter.
Right.
Okay, I see. Yeah.
Not every
Okay.
half. Every 1/4.
No.
Lambda 1/4. If you put m equal to 0, what you are getting? Lambda 1/4 or not? It is starting from lambda/4. Okay, and after that it is getting shifted by half.
Yeah. That's what I said. It's shifting by halves, and it's
Right.
Well, I said it repeats every half, but it's like shifted by one. Like it doesn't start at 0. It starts at 1/4. I meant like phase shift, kind of. Okay.
Right.
Yeah.
Okay.
Yeah.
Any doubt?
No doubt.
Okay. Okay then. Let's see. Okay. And also one more thing I just want to say to you. Intrinsic impedance, okay, of a conductor is 0. And 2 is intrinsic impedance of conductor. Okay. Okay. I have given everything in one page for this medium. Okay. Any doubt till now?
No.
Okay. Can we proceed to the question, right? Can we?
Okay. So you're just saying, sorry. Yeah. So you're just saying that impedance is 0 for a conductor.
Right.
Are there any other
See,
like
impedance is 0. That's why my reflection coefficient is -1.
okay, but there's no other assumptions we can make, right? Permeability.
No.
There's no like
No. Because it is
okay.
perfectly conductor. See, reflection coefficient is what? N2 minus N1 divided by N2 plus N1, right or wrong?
Yeah.
If I am telling that my N2 is 0, reflection coefficient is -1, right or wrong?
Right.
Okay. So everything are interrelate with every each other. Okay. From here you can get it, or from there you can get it. There is no issue. Okay.
Okay. Yeah.
Okay. What we will do, we will move to next page and we will try to get the problem. Okay. Can you see the problem and give your time 1 minute to read the problem correctly and
Is
try
this
to understand
5.3?
first thing. 5.3.
5.3? Okay. Okay. Yeah, I understand.
Okay. Basically, we have a plane wave. That's magnitude is given, right?
Yeah.
Right.
Magnitude is given, frequency
That
is
is
given.
100.
Yeah.
That is 100.
Medium.
Frequency is
Yeah.
given and propagating
Can
in
you
medium.
Yeah, can you go back to the previous page?
Yeah.
Okay, yeah. Never mind. We can continue. Yeah.
Basically, we have a medium. Medium 1. Medium 2. Right? And we have E naught given as 100. Right or wrong?
Yes.
Frequency is given as 150 megahertz, right?
Yeah.
Intrinsic impedance is 100 ohm, right? If the wave
Yeah.
is incident perfectly on a conductor, okay, this conductor, okay, So what we know, this is conductor, right? According to question, right or wrong?
Yes.
What is our knowledge saying that conductor has infinity? Intrinsic impedance is 0, right or wrong?
0. Yeah.
Okay. If intrinsic impedance is 0, then we can conclude that N2 minus N1 divided by N2 plus
It's
N1
minus 1.
is minus 1, right or
Minus 1.
wrong? If
And
incident
transmission
field,
coefficient is 0, right?
right. If incident
Okay.
field is going in this way, then we will have the reflected field, full reflected field in this way. Right or wrong? Right or
Yeah.
wrong? Okay.
Right.
So determine the following. Location of the first two consecutive nulls of total electric field in front of perfect conductor. Can you find it? We can find it, right?
Yeah. Yeah. So you have to find the wavelength, right? Firstly.
Right. First two, it means that n lambda by 2, and start from 0, right?
Yeah.
So 0 and lambda by 2 position we
Yeah.
have
So
found. First position
we
we
need to
know,
find
right?
lambda.
Yeah.
Yeah.
Okay.
So
Lambda
isn't
is what?
lambda like C divided by frequency or something? Or over VP?
Lambda will be Vp by F. Okay.
Okay. But
Okay.
we don't know VP. Yeah.
We know we do not know Vp. Okay. So what we know then? Do we have anything? No. We know N1 and we know
Yeah.
Vp in this form. C by epsilon r and mu r, right or wrong?
Yeah. But we don't know epsilon r.
Okay.
Yeah.
Okay. So one thing we can tell that our N1 formula that we learned, that this is mu epsilon naught into mu r divided by epsilon. Okay.
Oh, okay.
We
Okay.
know this one from our last
Yeah.
classes. Generally,
Yeah.
we used to put mu r equal to 1 because generally we are taking it as
Dealing
a
with free space or
non-magnetic,
air.
yeah,
Yeah.
non-magnetic medium. So it is epsilon. Okay. Now for this one, if we will tell this is our formula, and that is given as 100 ohm, right?
Wait, what formula is that one?
This formula we already studied, right?
No, the second one, and not over.
Yeah, second one we also studied. We can write it
Okay.
in this way or not. This is the N naught in free space. Divided by the permittivity of the medium. Okay.
But we don't know what N naught is.
N naught is 120 for 120. N naught means that free space intrinsic impedance.
Is that a set value or did you calculate that?
It is, we already know this, right? What is under root mu naught by epsilon naught? Till last 2 days we are taking this one equal to 377 ohm. Okay. Till
Yeah.
377 ohm. Okay. You forgot this one. This we studied, right? If you can see your
Right.
previous.
Yeah. Okay. I think I just forgot that formula. Okay.
Okay. That is equal to 377 or 120 pi. Both are equal. Many place you will get 377, many place you will get 120 pi. So basically
Okay.
your N1 is nothing but 120 pi divided by under root epsilon r, and
Right.
that is equal to 100. And
Okay.
from here we can get the epsilon r value.
Okay.
Okay. And that epsilon r we will put in the VP and we will get the VP.
Okay.
Basically, this epsilon r is nothing. If you find it, you will get 14.21 square. So epsilon r will be 14.21. Okay.
Yeah. So now we have epsilon r, so we can find VP.
Right. We can find VP, right? We can find
Yeah.
VP. That is Cy under root epsilon r. That is nothing but 3 into 10 to the power 8 under root epsilon is 14.21. Okay. Now it is like
Wait,
that.
wait. Go back to previous page for a second. Is it just epsilon r? No,
Right,
because mu
because
r is also in there.
yeah. Just now I told you that if nothing is given, then we are taking every medium as a non-magnetic medium. Okay,
I don't
if
know what
mu
that
r is
means.
not given, we always take it as a non-magnetic medium. Okay, it is like that only.
What does that mean?
If non-magnetic medium means that mu r is 1, that means that much only. Okay, if we
Okay.
have the magnetic medium, they will give you the mu r value. Okay,
No, but it said the medium is mu1 equals mu naught.
sorry.
It says that the medium of
Yeah,
and mu
mu
naught
1
is
is
1.
not mu naught. Mu r I'm telling mu r, not mu naught. Mu naught we have the value.
Oh, okay, got it. Okay, yeah.
Okay. Okay. So we can find now lambda, that is Vp by F, that is nothing but 3 into 10 to the 8, 14.21 into frequency is given, I guess 150
Yeah.
megahertz.
150 times 10 to the 6th. Yeah.
Right? If you'll find it, you will get 10, 5 into 14.21.
Okay,
You can calculate it. I'm not going through the calculation. I'm just writing the
fine.
value directly. Okay. Lambdas,
Yeah.
you will get some with 5.53 meter. Okay. Okay. Got it?
Yeah. Got
Right?
it. 0.53
Then we
meter.
can
Okay.
we can find location of first two nulls, right? That
Yes.
z equal to 0 and lambda by 2. So that is
Yes.
0 and 0.27 meter, right? Similarly, for the second one also, location of first two null of magnetic field z equal to 2n plus 1 into lambda by 4, right? So first two nulls will be occur when n equal to 0, right? When n equal to 0, it will be z equal to lambda by 4. When n equal to 1, it will become lambda by n equal to n equal to odd. For odd only, yeah, lambda by 4, and we will add lambda by 2, then what it will become? First null only. Okay, we have to find first null only. Okay, any doubt? Are you getting any doubt?
It said the first two nulls of the total
No.
electric field.
Yeah, total electric field, first null, two nulls, we already found.
Yes, and then magnetic field is going to be okay. Yeah.
Lambda by 4, you can put the values and you will get it, right?
Yeah.
4, you will get it 0.13 meter. Okay. Till
Yeah.
now, you have any doubt or not?
Got it. Okay.
Can you read the point that given below the question also obtain time domain expression? Can you read that line?
Yeah. Obtain the expressions for electric and magnetic field and determine amplitude at the surface of the conductor and at distance z equals -2.
Okay. Got the what the question is telling, right? So basically we have to find here electric field and magnetic field. Yesterday I told you that electric field is a function of position and time, right?
Yes.
So now I am writing it is in different form. Okay, because we have in the z and t. Okay, so that you should not have any type of confusion. You can see electric field as EZT. That should be what? E naught. Okay.
Okay.
Just a minute, 1 minute. Just a minute. What is how they rate sine over that's okay. Equation for okay, 1 minute. Okay. Before that, in this case, I haven't given you one more formula will be there. Okay. Before taking these things, see, we have which medium? One reason one as a any other medium and reason two as a conductor, right or wrong? Hello.
Yes, right.
Okay. So, what is the total electric field? Can you tell me in reason one? Is it be incident field? If I'm taking z direction and reflected field in z direction, can I say in this way?
Yeah.
Okay.
Yeah.
I'm not going to derive it. If you will derive it, you will get that total electric field is 2E naught sine beta 1z sine omega t ax. Okay, this is the total electric field if total wave are getting reflected back. Okay, any doubt?
No.
Okay, and total magnetic field, let's give you the total magnetic field. It is nothing but two E naught intrinsic impedance of medium cos beta 1z cos omega t ay. This is your total magnetic field. These things you have to remember. Okay. Any doubt till now? Any doubt?
No.
Okay. Now, what parameter you have? Do you have E naught or not?
Yeah.
Do you have beta 1 or not? Beta 1 we do not have.
No.
Beta 1 we can calculate, right? What do you mean by beta 1? Beta 1 is nothing but 2 pi lambda, right?
Yeah.
And lambda was what? 5 point something, right? If I'm not wrong.
0.53.
0.53. Okay. If we'll
E
calculate.
naught is the amplitude, right?
Yeah,
Of the
amplitude.
wave.
I used to write E naught. You can write in the
Okay.
EM, whatever way you want. Okay.
Sure. Yeah.
Okay, of the electric field. Okay. You can
Yeah.
get beta 1 as 11.84. Okay.
Yes.
And we have N1, right?
Right.
Right. We have the N1
And one is
and
100.
N1 is 100, yeah, whatever value. Okay. And omega we can find, right? That is 2 pi into F.
Pi F.
Omega is
F.
nothing
Yeah.
but frequency in radian,
Yeah.
right?
So it's 300 pi megahertz.
That is 300 megahertz was there, right?
300 pi because it's 2 pi. Yeah.
Frequency was what?
150.
It was 150. Yeah, it will be 300 pi into 10 over 6. Okay. So you will calculate it, you will get it 9.4 into 10 over 8. Okay, this is over. If you'll put all those things there, you will get E total as 1200 sine beta 1 11.84 z sine 9.4 into 10 to the power 8 ax. And similarly, you can find h total as 200 divided by n1. Okay.
I have a question. Well, I have a question.
Yeah. Tell
So
me.
the E total in this case is the incident plus the reflected. But what about if it wasn't a conductor and like there was a transmitted portion as well? Would it still sum to the same formula, or would
No,
it
no,
be
no,
different?
no. It won't sound to the same formula. Let me see you. This is your E incident, right? Then
Yeah.
what we will do, we will just like our previous question yesterday, we were finding E incident only. After that, we will finding E reflected, right?
Right.
Then we will add up those. Are you getting it? Are you getting it by my point? Or let me open if I have that one. If I have that one, let me open it. If I had that slide, then I will tell you. Let me check. No, I'm not getting that slide. 48. That slide now, then you can easily tell me that. Yeah, yeah, this was slide, right? Are you able to see it?
Yeah.
Okay. Here, what we were doing? We were doing the E reflected and E incident one by one, right or wrong?
Yeah.
Here, if I consider that what is our total, E total, then it will be nothing but this summation. Okay. E total will be EI plus ER. Okay. And what was EI? EI was 100,000 cos pi t minus beta z. Okay. Plus.
No, but what if there's a transmitted portion as well?
There will be transmitted. But what will be the total? Total in one medium we are finding, right? Transmitted will be going into the other medium. Why we should bother about that?
Okay.
See, here the thing is get simplified because nothing is getting transmitted.
Got it. Okay.
Okay. So in that way, you can just add up this thing also. Okay. You will get it.
Okay.
Like that. Okay.
Yeah.
Any doubt? Okay. Can I
How
move
do you
to
add those together? How do you add those together?
just normal addition? Because both are in same direction, just
Oh,
the
same.
reverse.
Yeah. Okay. Okay.
Right, just it will be the minus,
So
right?
it'll just be 620. So it'll just be like 620 cos, like 1,000 minus 380.
No. It won't be like that because we are just adding the vector only. We can't add it at the magnitude because it is in plus z. Sorry, incident is in plus z and reflected is in minus z. We can't add in that way.
How do you add those two together? Or is that just the total value? Like
We are just
simplify that?
adding the vector. I'm not telling that I'm getting the result. I am adding the vector only.
Okay.
Okay.
Yeah.
Okay. Let's come to the our current.
So you can't simplify that is my like you
No,
can't
no,
simplify.
we can't. No, we can't simplify that.
Okay. All right.
Okay. 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 E total here will be 200 divided by 100. Basically something. Okay. And that will be cos 11.84 z sine 4.8 10 to the power 8, something like that, and you will get the answer. Right.
What does that say? 4 point. It's written very small. What does that say?
9.4.
4.8?
9.4.
Can you rewrite that a little bigger, please?
Nine point eight into 10 to the power 8. Okay.
Yeah.
Okay, that will be basically those things, right? Are you getting it,
Yes,
or you have any doubt?
no doubt. Did you stop streaming? Hello? Uh, did he crash? Hello? Hello.
Yeah, hello.
Hello.
Yeah, hello. 1 minute.
Is everything good?
Yeah, yeah. Yeah, OneNote is not responding. It got hanged. So I will teach on this Zoom note. Okay.
Okay. Yeah. Just make sure I get the notes from both things.
I don't know about this one because I rarely used. I think
Oh.
we can get this one also. Let me
If
that.
we can't, if you no, because if we can't, then let's just continue later. Because I really
Yeah,
like
it's okay.
if I don't get the note.
Okay, let's get it. Okay. Okay, yeah. Till this question, it's okay. I will take extra 5 minutes. There is no issue. Okay. 5 minutes is lost for you. Okay, this question is okay for okay, right or wrong?
Yeah.
Okay.
No, so do you know if I can get the notes from this or no?
I'm sharing in the OneNotes only.
You're what? I did not understand what you were saying.
Yeah. Let's take up
Did
question
you
5.4.
understand what? Did you understand what I was saying? Sorry.
My screen is visible or not to you? My screen is visible or not? Hello?
Yeah. Did you understand my question? Like, will I be able to get notes from
Yeah, you will get
this
notes. You will
person?
get notes. Right.
Okay.
You have the recording also, right?
Yeah, but I mean I prefer the notes for review. But yeah.
Yeah.
Okay.
Okay. Can you read the question number 5.4?
Did we finish 5.3? Did we get the total magnetic? No, we didn't finish
Didn't
5.3.
we got the
No,
total,
because
right?
we got the total for electric. Did we get it for magnetic as well?
Right. We did get it.
Okay. Well, then we have to find the amplitude at the surface and at distance z equals -2. I don't think
Just
we
put z equal to -2 and you will get it. Okay.
Okay.
You will get it.
Okay. All right.
Okay. You will get it.
Yeah. Okay. Fine. Sounds good.
Okay. Now uniform wave is,
Yeah.
can you read the question number 5.4?
Yeah. Yeah. So uniform wave, lossless medium, and perfect conductor, 400 megahertz.
Right.
If the measured distance between any two successive zeros of the total electric field in front of is 12.5, determine relative permeability or permittivity, shortest distance from the conductor at which, okay.
Okay. See what is given. Frequency is given, right? 400 megahertz.
Yeah, frequency. Oh, and then the distance between any two of the total electric field. That's 12.5.
What is that
And
distance between
that's
total
lambda
electric
over
field?
2. Lambda
Right.
over 2, right?
Is
Yeah, so then
given.
we know lambda. Then we know lambda. So lambda
So
is going to be
lambda 1 will be
25 centimeters.
25
So that's,
centimeter.
yeah,
That is nothing but 0.25 meter, right or wrong?
yes, right.
Okay. Okay. Lambda 1, right?
Yeah,
And lambda is what? Vp by F, right or wrong? Lambda is Vp by F or not? Lambda 1, lambda. Hello.
yeah, yeah. Are you
Okay.
writing this? I don't see if you're writing it or not.
You're not seeing my screen is already shared.
I am seeing your screen. I see no writing on it though.
Okay, let me reshare it.
Oh, okay. Yeah, now I see it. I think you were still on the other one, other application. Okay.
Okay.
That's why I got confused because it was still on the other application. Okay.
Okay.
Yeah.
Okay. Got it.
Yeah. Yes, got it. So then you can find relative permittivity as well, right? From that.
Right. We can find the relative permittivity that is equal to 0.25 meter. Right.
Right.
And frequency is what? 400 megahertz. You can find the relative permittivity then 3 by 4 into 0.25, that is 3. Then your relative permittivity will be nothing but 9. Okay, got it?
Got it.
Okay, now determine the following. Relative permittivity, we got it, right? Question number 1. Okay, question number we got it. Question number 2 for this one. They're telling that if the shortest distance from the conductor at which total magnetic field is 0. Okay, what we learned? That shortest distance from the conductor was that for total magnetic field is 0. We learned this one, right or wrong? Right or wrong?
Right. Right.
For the shortest is what? Lambda by 4. Now telling that for the conductor to be 0, it means that if you calculate, if you tell this is 0, then this is lambda 1 by 4 minus, right or wrong? That distance.
Right.
Okay. So shortest distance is what for which lambda is 0? That will be minus lambda 1 by 4, right? And that is nothing.
Yes.
Lambda is given there. That is 0.25 minus 0.25 divided by 4. So you will be getting minus 0.0625 meter. Okay. This much you will be getting. Any doubt?
No doubt.
Okay. Now coming to the third question. If the amplitude of the incident electric field is given, calculate the magnitude of the magnetic field at distance z equal to 0.2. Okay. So basically they have given E naught equal to 120 volt per meter, right or wrong?
Yes.
Okay. What is the magnetic field? Magnetic field is nothing but E naught by N naught. Okay. We already have the equation of the magnetic field in the conductor, right? Here is what? 2 E naught by N1, right? Cos beta 1 z cos omega 2, right or wrong?
Right.
So 2 E naught by N1 cos beta 1 z cos omega 2, right? And what is N1? Right or wrong?
Right. Okay.
Okay. Any doubt? Any doubt here?
No doubts.
Okay. Basically, if you calculate it, you will get 1 is a 40 pi. Now you got it. This is 2. E naught was given, right? 120. N naught is 40 pi cos beta 1 z cos omega t. Beta 1 is nothing but 2 pi by lambda, right? Lambda is given to you. We already found lambda as a 0.25. So beta 1 will be nothing. Beta 1 will be nothing but how much will beta 1? It will be around 8 pi. Cos omega t 2 pi by lambda. Beta 1 will be beta 1, if I'm not wrong, it's not 8 pi. Splitting it 8 pi. Yeah, it is 8 pi. Okay. And omega is 2 pi f. That is 2 pi. What is f? 400
F is yeah.
right? That is 8 pi into 10 raised to 8, right? Hertz,
Yeah.
right or wrong?
Right.
Okay.
Okay.
So h is what? H is what? 6 by pi, right or wrong? If you calculate it, cos beta z is 8 pi z cos omega t, that is 8
How did you
pi.
get? Oh, okay. Yeah. I see. Okay.
Okay, 6 by pi is
Yeah.
what? If you calculate it, you will get 1.91. Okay, cos 8 pi z cos 8 pi into 10 raised to 8. Okay,
Okay.
now your z equal to 0.8 meter, right? Now it will be 0.8 at t. Okay, if you could put those values. Okay, basically what they are asking, that calculate the magnitude of the magnetic field at a distance z equal to 0.8. Okay, 0.8 from the surface. So it means that we will put it negative, right or wrong?
Yes.
We will put it negative. So if you put the negative one, cos, you will get minus 6.4 pi cos 8 pi into 10 raised to 8 t. If you calculate it, cos 6.554, this parameter, you will get I don't have the calculator. You have to calculate it basically to get these values. You have to put cos minus 6 pi. You will get some answer, and they have put the answer in this same fashion only. So there is no require. So it might not be the requirement for them to do those things. Okay.
Okay. All right.
You got it or not?
I got it.
Okay. Okay. Now find the magnitude and direction of induced surface current. Okay. We have we got the magnetic field, right?
Yes.
Right or wrong? And we have one formula for surface current. Because since you have started from chapter 5, so I'm not going in that way. I'm just directly writing that values. Surface current Js is nothing but N cross H1 minus H2. H1 is magnetic field in medium 1. H22 is magnetic field in medium 2. Okay, and this N is the vector direction that will be pointing to the direction of the wave propagation. Okay, and this one H1 and H2. Okay, since there is no this since my second medium is perfectly conductor, so I can say that magnetic field inside perfect conductor is 0. Okay, so we have N cross H1 as Js. Okay,
Okay.
and Js is N is minus AZ, and H1 is what? H1 is 1.91 cos minus 6.4 pi cos omega t minus 0. Okay, And this
So the
direction,
JS formula, that's from a previous chapter, right?
yeah. This formula for this, you have to go to chapter 2 or something like that. Okay.
All right.
Okay, and AZ cross A1 is giving you AX. So basically, your answer will be 1.91 into cos of minus 6.4 pi cos omega t AY. Okay, this is your the answer that you will be getting, and its unit is ampere per meter. Okay, any doubt?
No doubt.
Now you have some theory part. It's basically a lot of theory part I'm seeing. Explorized electric field with a magnetic revolution. Okay. 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 Till now it's okay for you, right?
Yeah.
Okay. Now you have to see a lot of theory parts are there. We have to plane wave characteristics in front of reflecting surfaces. We have to find those things also, but I don't know how much you know the theory part. That is the major problem that I'm saying it. Do you want me to cover all these theory parts? Because all these theory part will be related to, in the question you will get the theories question from this theory part. I'm saying that
Yeah.
these things will be used there
Oh,
in
okay.
so
Yeah.
we have to learn these theories, otherwise we cannot do those questions. Okay, in that way we can do it.
Okay. Then yeah, I think we have to go over the theory part.
Right. There's nothing we can do, right? Okay, we can start
Yeah.
with 5.3 3.1. I will try to make it as much as shorter as possible. Okay, in our earlier discussion we considered the special case of reflection, right? That we have a conducting surfaces here and we have another surface. In this, the total field in form of perfect conductor were standing waves. If the word standing wave is coming, it means that it is a combination of electric field and magnetic. It is combination of the reflective field and incident field. Okay, incident field and reflected field combines to make standing waves. Okay, the electric field formed standing wave with permanent location of nulls at the surface of the perfect conductor and were spaced and lambda by 2 from the location of first nulls. Okay, so they are saying that if we have one medium as a conductor, okay, if we have one medium as a conductor, then my first nulls is appearing at the surface. Okay, this is my incident field, this is my electric and reflected field. So first nulls was coming at the center. For z I told you n lambda by 2. So first nulls will appear at the surface. After that, every nulls will be lambda by 2 separated from each other. Okay, but it's not the
Okay.
case at every time. See,
Okay.
this is conductor, that's why it's happening. Because at the conductor surface, the magnetic field become 0. But suppose we have one medium here and we have another medium here. So it's not necessary that, and second medium is not conductor. It's not necessary that the maxima or minima will occur at the surface. It's not like that. It can appear at any position. Okay. Since in our earlier cases, it was conductor. So that's why it was appearing at surface. Okay.
Okay.
Okay. The question is, what would happen if the reflecting surfaces has not been perfectly conductor? To begin with, reflection coefficient, first of all, in that case, reflection coefficient will not be 1 equal to 1, right or wrong?
This is for 5.4, right?
No. This is 5.4 we already completed.
Or sorry, 5.5. So like this is theory for 5.5.
For theory for 5.5, you have to learn a lot of theory. It's not like that simply you can jump it. you can see before 5.5, there are a lot of theories there. We can't jump directly to 5.5. That I was telling you.
Oh, okay.
Okay,
Yeah.
if you
No,
can read by, yeah, tell me.
like I'm saying, like what you're explaining now, this is like theory for 5.5.
Right. A lot of theory will be there. Okay.
Okay. Yeah.
That I'm just relating it that what we learned till now. Till now, we learned that this is conductor. This is one reason. If wave is getting going, then wave was totally reflected back, right or wrong? And at the
Yeah.
surface of conductor, electric field was zero. Since electric field was zero at the surface of conductor, we were concluding that on the surface at z equal to zero, we are getting one null of electric field, right or wrong? But it is not the case at every time. Suppose this is my one medium, this is my second medium, and that second medium is not conductor, then we will not getting the electric field null at the surface. We will be getting at some other point. Okay, it might be at
Oh,
this
okay.
point, it
Yeah.
might be this point. That
Okay.
theory we have to learn.
Got it. Okay. Got it.
Okay.
Yes.
Understood? That theory we have to learn that how we can find those null point,
Okay.
basically.
Got it. Yes.
Right?
Okay.
Okay.
Understood.
Okay. To begin, in that case, the reflection coefficient will not be equal to 1, right or wrong?
Yeah.
And at
Right.
location where the incident and reflected wave distinctly interfered, there will not be complete cancellation of incident and reflected wave in other wave. Instead of location of nulls, there we will get location of minima. Okay. Here we will get location of minima and maxima. Here we will get location of minima and maxima. Okay, here we will get location of minima and maxima. Okay, basically
Yeah.
it's like that
Okay.
only because we will not get the null. See what
Okay.
happens? This is our incident field and this was our reflected field. So
So
complete
sorry, I
cancel.
have like one question. I have one question.
Right.
So you have access to all the problems that you have access to all the problems, right? That I sent, like the problems I need to go over.
You have sent me a paper. You have sent me a book, right?
The book as well as like the lecture, like which problems to go over, like which sections, which problems. You have that, right? It was like an image I shared with Aditya.
Yeah. Wave at
Okay.
planar interface, right?
Yeah. So there were problems like after 5.4, there were problems associated with it, problems 5.2, 5.3, 5.7. Would it be better to go over those first, or would it be better to cover all the examples and then go over all the problems?
Problem 5.23, we discussed it, right?
No, we went over example 2, 3.
Okay. Okay, you are telling that go to the problem number 5.237.
Yeah.
Okay.
It should be at the end of the chapter. There should be a list of problems
Okay.
that are separate from the example ones.
Okay. I should have told me that earlier. Can you point me to the page number? Exact page number. Can you exactly point me to the page number? Yeah, I'm getting it. Yeah, which problem of 5.2 you are talking, right?
Yeah. For some reason, my PDF is moving very slowly, so I'm not able to find. Okay, yeah. It's around page 506. Yeah, 506.
This one, right? 5.2. Problem number is what the problem number? Can you tell me? 5.2 or 5.6?
Yeah. No, 5.2, 3, and 7.
Okay. This is your 5.2. Okay, basically you want whatever is written there, right? Only those parts, right? Okay, you could have told me that.
Well, it was in the list of the problems I gave you.
Yeah,
And
but
I was asking, yeah.
yeah, it was very hard to decode it, right? That what is specifying there, because the image was yours, so I'm not able to decode what is how we have to go. Okay, there is no issue.
Well, oh no, I sent text. So I sent the text to Aditya. I said that E refers to examples, P refers to practice problems.
Yeah, but yeah, you should have told me here, then we can. Yeah, anyway, there is no issue.
Oh, okay. No, then
that
we
was a
can.
concept.
I mean, do we just
Yeah.
want to? Because we're only going for 1 hour today, right? So I mean, we can just
Okay, we
start
can
that tomorrow.
we can conclude tomorrow for today. Okay.
Yeah.
Okay then.
We can just we can, if you want time to look it over, we can just continue. We can just start that tomorrow. There's no issue.
Right. Okay, Liam.
Okay.
Okay, bye.